This is me throwing a bucket of rock flour onto a field in Germany. I'm doing this mainly for my young son's future, because this rock flour has the potential to reverse climate change. This video is about producing negative emissions with magic stones that possess the power to make CO2 disappear.
Not just stopping the emissions, but also take carbon out of the atmosphere.
How fast can we capture CO2 on 1 hectare of agricultural land?
No, I don't possess the philosopher's stone. But this is a basalt rock. A long time ago it was lava. Now it is one of the most common stone types on our planet. Besides its vast availability, it has a special quality. In oversimplified terms, it absorbs carbon. We will take a look at the magic of science behind that, how we can make use of this and how big the potential is. It's insanely big. In full transparency, this video is sponsored by the Carbon Drawdown Initiative. But everything I say is my honest impression, and I just work with companies that I think are doing good for the world. Before we talk about solutions, we need to understand the problem. And for this, we need to understand only one principle, which is considered to be a given by science. The average temperature on Earth is directly connected to the amount of greenhouse gases in the atmosphere. This means temperatures rise if we add more CO2 into the air than is taken out, and falling temperatures if we manage to reduce the amount of CO2. For the past 10,000 years, the Earth's natural carbon cycle was in balance. Then, about 150 years ago, we humans started digging coal, gas and oil out of the ground, burning it and thus adding more carbon into the atmosphere than our planet can naturally absorb. As a result, the CO2 concentration increased and the Earth has become warmer. The consequences of a warmer Earth are largely known by now, so I only will mention them briefly here. Ice masses melt, causing sea levels to rise, and many cities with millions of people becoming uninhabitable. At the same time, warmer air can hold more water vapor, which dries out soil needed for food production. And when it rains, there is simply more water in the air that can pour out in short periods of time. This means that in order to stop the further rise in temperature, we have no choice but to achieve zero carbon emissions. After that, the temperature then stabilizes, and very importantly, the Earth does not cool down by itself. Our real problem is that we are very used to our level of prosperity and have established various processes, for example in industry, for which we do not yet have any completely climate neutral solutions in sight. And that's exactly the point. Even if we reduce our emissions by 90%, and maybe even limit ourselves further to reduce emissions by another 5%, we would still be adding greenhouse gases to the natural carbon cycle, and the warming would continue with all its cruel consequences. So in order to stop global warming to begin with, I think it's unavoidable that we, of course, drastically eliminate greenhouse gases in all areas. But at the same time, we need to figure out how to remove CO2 from the air in order to bring the energy balance of our planet back into a safe range for us. I asked Jelle Bijma from the Alfred Wegener Institute if we could just use trees to get carbon out of the air.
Well, the reason to go for rock powder and enhanced weathering instead of going for trees, which is also a natural way of taking CO2 out of the atmosphere, is quite simple because, first of all, taking rock powder will take care of the CO2 on geological timescales. As we know from the fires in Australia, in California, in Siberia, we know that trees are not a very stable place of storing carbon. They burn and they just give it off. And if they don't burn, they will rot. It is not an option. The other reason is that we don't have the area needed for planting trees to become an effective measure of taking CO2 out of the atmosphere is simply not there, because we need it for food production, we need it for our infrastructure, and the world population is growing. So we cannot just plant forests all over the place, although it would be beautiful.
Which brings us back to this basalt stone. One of the possibilities for negative emissions is called enhanced weathering. Just like photosynthesis, this is another natural process, but here the CO2 binding is permanent. But because of the wheels of public funding programs turn slowly, this method has not yet made it out of the laboratory and into the field. Until now. The two companies Carbon Drawdown Initiative and Field Code have teamed up with some of Europe's most respected scientists in the areas of climate and geology, as they have realized how much faster we need solutions here. I had a chat with Dirk, the founder of Carbon Drawdown Initiative, about Project Carbdown.
We started Project Carbdown because I met some scientists, for example Jelle Bijma, and he told me that he was unable to get funding for a project like this. And so we stepped in and we started the project in less than 6 months, and he would have waited 2 years.
So the two companies have built within months what would have taken at least years in the normal scientific system. Now, how does that work?
Basalt and olivine are naturally reacting with the CO2 in the air. This is Earth's normal way of controlling the CO2 in the air. But that usually takes hundreds of thousands of years, and we speed that up by grinding the basalt or the olivine very, very small to have a very large surface. And then you also have to add a little bit of water because the chemical reaction does need water. And then you can capture CO2 from the air with just rock flour.
You can imagine this reaction like this. Basalt stone comes into contact with water and CO2, thus starting a slow chemical reaction that causes the basalt stone to weather and in the process produces harmless carbonates from CO2 and H2O. The important thing here is that afterwards there is less carbon in the air than before. This process has basically always been present on Earth. Dirk has already said that these processes take a long time, but by grinding we can increase the surface area of the rock to such an extent that we can extract considerable amounts of CO2 from the air. This is what enhanced weathering is all about, accelerating natural processes to remove carbon from the atmosphere. And you know what? We already have all the technical requirements for this. We are already mining basalt in quarries. We have been crushing and grinding rocks in quarries for centuries, and we are already spreading rock flour on agricultural land as a fertilizer.
The advantage of our approach for enhanced weathering on agricultural land is that we do this while the farmers continue to use their land. So there is no competition for space.
In essence, we already know that we have the necessary technologies. The land on which you can do this is still usable, and the CO2, once it has been transformed by the rock particles, is bound almost for eternity, so it cannot be outgassed again. Plus, the rock types are available in gigantic quantities.
To get an idea how much CO2 we can capture with our approach, we have calculated that if you apply 40 tons of basalt on 1 hectare on all of the agricultural land that is used in Germany, then we are at the same order of magnitude like the current emissions. And as you know, we have to reduce the emissions by 80 to 90% anyway. So we are at least in the same order of magnitude as the problem is. And there are very few solutions for CO2 capturing right now which are in the same order of magnitude at all.
I want so much for this to work. Of course, this is only a very rough projection. What is missing are really concrete values and above all, practicality.
So the best case scenario that we see until fall this year is that one of the metrics that we already measure in our fields is able to act as a proxy for how much CO2 we can capture in 1 year. And we need these metrics to make a proper accounting of how much CO2 we can capture on 1 hectare, on 2 hectare, and how much of the stone flour we have to put on that to get this reaction.
And this is exactly the key to success, because we already know from laboratory studies that it works, but we still don't know how quickly it works out in the field, and above all, how we can easily measure it. But that's exactly what's essential. Because who should pay for the application of some random rock dust if it's not even clear exactly how much CO2 is collected?
We need accounting because we want to give the farmers an additional income by putting basalt on their fields. With our accounting, we can calculate how much CO2 the farmer has captured, and he can get money for the CO2 certificates that are generated on his field.
They are not only doing this test in Fürth, where I was on site, but also on fields in Bramstedt, Wageningen, and on a cotton field in Larissa. Lots of different sensors are buried and installed in each field.
The key question is, how fast can we capture CO2 on 1 hectare of agricultural land? Our goal is to have good results, first results in fall of 2021, but actually we are measuring metrics every 20 minutes on our fields, and we are taking water samples every week. We are testing soil samples. We have pot experiments in a greenhouse, and we have box experiments in a lab. So there will be a lot of learnings over the whole year 2021. So I think we'll be able to tell a story over the whole year whenever we've learned something new.
To summarize, we need methods to get carbon out of the atmosphere. Second, we know that certain rocks, like basalt, have the potential to do that. The rocks are widely available and we have all the technology to do that. Third, the potential is huge. We just need to find a way to scale it and speed it up. The team behind Project Carbdown is building the necessary foundation for that as I record this. To be honest, this is one of those projects that gives me hope that we can stop the climate crisis after all, and my son will be able to have a life worth living. In most places, avoiding emissions is clearly cheaper than buying negative emissions. After all, the sooner we become carbon neutral, the cheaper it will be for us as a society as a whole, because we will avoid massive damages. Once we have achieved net zero, we can then also get our pile of CO2 waste out of the atmosphere and bring our planet back into a safe range for our children and grandchildren. If you want to do something to promote enhanced weathering, there's probably not much that you can do at the moment, except to spread this topic as far as possible and bring it up in discussions. By doing that, we can already create the necessary political foundation. In the next video, I would like to go deeper into enhanced weathering and explain exactly how it works with basalt. See you next time. Bye.
Can we do it? I would say, well, we managed to increase the PCO2 and incredibly fast and with lots of carbon. There was a whole industry, the petrochemical industry that used it. We are using cars. We can change that, but we have to be fast.